It's time for the most popular game, Prisoner's Dilemma. You may have heard about it before. Let's analyze this game with what we just learned. The game is simple. A husband and wife are brought into a police station to investigate a crime. They really are guilty, and will be questioned separately in the different rooms. There are 3 hypothetical scenarios. First one, if one confesses while other denies, denier goes to jail for a long time while confessor is rewarded. Second scenario, if both confess, they both get a moderated punishment. And the last one, if both deny, they both get away with a very little punishment. In this example, remember that before talk is not possible. Because this is a simultaneous game. So they know nothing about each other's decisions and they have to draw a conclusion by their own. Let's represent this game with a normal form table. Here, you can see the outcomes for possible scenarios. If both confess, they get 10 years for each. If one confesses and other denies, the one who confessed gets 1 year and the other one gets 25 years. Finally, if both denies, they both get 3 years. Alright, now that we know the normal form of the game, let's look at it from the husband's perspective. If wife confesses, what would husband do? He gets either 10 years by confessing, or 25 years by denying. Then we can say that, if wife confesses, husband will also confess. For the other option, if wife denies, husband will get 1 year by confessing, and 3 years for denying. So again, confessing is the best option for husband. Things are same for the wife's perspective since this is a symmetric game. Okay, I would like to mention here we don't consider any ethical or emotional issues, and just speaking logically. Confess is the dominant strategy for both players. Deny is the dominated strategy. These are well-known terms in game theory. Now, we can eliminate all the dominated strategies. Here wife denies. Here husband denies. And here, they both deny. After eliminating all the dominated strategies, we left with only one cell. So, when we eliminate all the dominated strategies, if we end up with only one outcome, we can say that the game is dominant solvable. This is another technique to solve these type of games. Again, you eliminate all the dominated strategies. And if you end up with only one single cell, the game is dominant solvable. But, is this result Nash equilibrium? You may stop the video here to figure it out with your own. Let me clear the table first. So, we're going to check if this cell is the Nash equilibrium or not. Is there any better strategy for husband to change it? We are looking from husband's perspective, so we should fix the wife's decision. When wife confesses, should husband change it to deny? No, he doesn't want to get 25 years. Wife also doesn't want to change her decision. So we can say that the confess-confess strategy is the Nash equilibrium. In the table, we have a cell which is better for both wife and husband. That's why, our solution is not Pareto efficient.